going to be presenting to you today about ore pre-concentration, in particular cutting costs through ore pre-concentration. So what is ore pre-concentration? I think the best definition that I found for ore pre-concentration is that it's essentially the removal of barren material early on in a process at the coarsest possible size as possible, thereby reducing the downstream comminution and processing requirements. So there are many ways in which we can go about ore pre-concentration, but the focus of our presentation today is on sensor sorting. So what is sensor sorting? Sensor sorting is the separation of particles based on their discernible specific properties. In other words, we can use a variety of sensors such as induction, color and laser, dual XRT, X-ray transmission, and near-infrared to separate particles based on their characteristics. In many cases, we do combine these sensors in one unit. So what I'm showing now is the typical application of a sensor sorter in which we've installed a sensor sorter after the secondary crushing stage. However, you can install a sensor sorter after the primary crushing stage or tertiary crushing stage. For particles or for materials such as coal, we can go to particle sizes of up to 300 millimeters. So how does sensor sorting work? Essentially what happens is that material is discharged onto a feeder. This feeder then creates a single layer which discharges onto a conveyor. Now, as the material moves along the conveyor, it passes through a number of sensors. So this could be a single sensor or a combination of sensors. The material then moves on and a signal is sent to an ejector bank, valves that then eject material. So what happens is that depending on what you've selected to eject, you could either eject on waste or on your product. So the material that's ejected then goes to the far end of the sensor sorter, and there's a splitter plate that separates your ejected material and your accepted material. So the material that's accepted, so in this instance, let's say product, would then fall behind the splitter plate. This is an alternative view of a sensor sorter in which you've got a vibrating feeder, a conveyor belt, a control cabinet, which then instructs the valve bank on when to shoot material. So the material that's shot goes to the far end of the sensor sorter, and that's a splitter plate. And the material that's accepted comes behind the splitter plate. This is what your X-ray gate would. This is where your X-ray gate would typically be located. However, this could be replaced by another sensor such as a near-infrared sensor or a combination of sensors such as color and X-ray. What I'm going to be showing you now is actually what it looks like in most sensor sorters. So the material that you see following an upward trajectory would be your waste, and it's going to the far end of the sensor sorter, and there's a splitter plate that's separating the material that's following a downward trajectory. As you can see, the material on the conveyor belt is in a monolayer, and your sensor would probably be located, or is typically located behind here where you see the light. And that's your valve bank. So essentially material that's coming off the conveyor, your waste particles are being shot and they then follow an upward trajectory. One of the main questions that we get when it comes to sensor sorting from clients is which sensor is applicable for our material, and the go-to answer for that is typically X-ray transmission. So we found that the XRT works on most commodities. However, as I mentioned earlier on in the presentation, that we can combine a number of these sensors in one unit. So we can combine the XRT with the color and laser sensor in one unit. What I'm showing now is a case study that one of our partner companies worked on recently. And what was happening is that they were treating about 350 tons per hour of a zinc ore, producing about 35 tons per hour at 48% zinc. However, with the installation of a sensor sorter, that material was reduced in terms of the material going to the final processing plant, because approximately 50% of the material was removed upstream. And so the same amount of product was produced, but a lower amount of material was going to the processing plant, resulting in a 46% in plant operating costs, as well as a 46% reduction in transportation costs. The transportation element comes from the fact that the processing plant was located at quite a considerable distance away from the mine. So what are the benefits of using sensor sorters? I think the best answer that I can give there is that every single ton of waste in the tailings pond has incurred costs that sometimes may not be necessary. So with sensor sorting, essentially what you're doing is you're removing waste early on in the process, thereby reducing your crushing and screening requirements, your milling, energy, and process water requirements as well. You also have a reduction in your flotation, pumping, and piping that you would require in the plant. Ultimately, you have a reduction in the amount of material that you're taking to the tailings dam. And one of the major benefits of using sensor sorters is that you can now treat material with a lower cutoff grade, and you can recover marginal grade material such as your old dumps. So an example of this is shown in this particular slide, where one of our partner companies is working on a case study in which a mine is treating old dumps that are located about 200 kilometers away from a processing plant. So what they have recommended is the installation of a sensor sorter, and what that has shown is that approximately 30% of the material will be sorted at the old tailings, at the old mine dumps, and would therefore not require transportation to the processing plant. Therefore, what ultimately happens is that your transportation costs are reduced and you free up capacity in the mill and in the processing plant. One of the projects that we're currently working on at IMS is an old manganese mine in the Northern Cape, whereby we're treating, whereby one of our clients is currently treating old dumps. And at the present moment, it's a simple process. They're currently screening the old dumps and selling manganese at a 28% manganese content. So what we've recommended is the installation of a sensor sorter. And what we found in our test work is that essentially we can remove mostly silicates from the ore, producing a manganese content of up to 45% in manganese. So the base case for this case study was a single shift, because that's how the mine is currently operating at present. So what we found is that the payback period for that is about 2 years if we're using a 1 meter sorter, whereas if we then use a 2 meter sorter, we have a reduced payback period of about 1.3 years. And the return on investment on each of these sorters ranges from 50% to 80% for the 2 meter sorter. We then did a sensitivity analysis for the client, whereby we then showed that if they had to move from a single shift to 3 shifts, they could reduce their payback period from about 2 years to approximately 6 months. And one of the issues that the client was having was that their transportation costs were quite high. So they were only receiving about 250 rands per ton at the port, whereas they then indicated to us that if they optimize their transportation route, they could get about 450 rands per ton. And that would then significantly reduce the payback period from about 2 years to approximately 3 months if they followed the 3-shift route. And similarly with the 2 meter sorter, the payback period is reduced from about with a single shift 2 years to approximately 2 months if they then take a 2 meter sorter at an incremental revenue of 450 tons per ton. Sorry, 450 rands per ton. Coming to a conclusion of my presentation, ore pre-concentration is essentially the removal of barren material early on in the process, creating financial, operation, and environmental benefits. So essentially what would happen is that you have a reduction in your capital and operating costs. However, there's an added environmental benefit as well, in that in most cases, sensor sorting is a low cost, is a low energy consuming process. And so by reducing the amount of energy that you use, depending on your grid, you then have a reduction in your greenhouse gas emissions. And for the XRT sensor, it's a waterless technology, and therefore it's a dry technology, which means that you're reducing your water consumption. That brings me to the end of my presentation. Thank you.